Dr. Karim Galal, the floor is yours to start the workshop presentations.
Thanks, Dr. Debbieh. Hello, everyone. Of course, it's my avatar. I'm Karim Galal, Associate Professor at the Faculty of Architecture, Design and Built Environment, Beirut Arab University, and the coordinator of the Virtual Reality Lab, which concerned with 3D laser documentation, virtual reality, augmented reality, and their applications on architecture design. On my background, you can see the latest project of BEU VR Lab, the 3D scanning of Bab Sarai Square in Old Saida, Lebanon. Now we will present the workshop conclusions. Along the ASCAAD conference 2022, BEU hosted 5 workshops on 10 and 11 of October, addressing the main theme of the conference. The workshops were conducted by distinguished workshop organizers in the fields of augmented reality, parametric design, BIM, and GIS. Over 80 participants were engaged in these workshops. They are distributed between undergraduate and postgraduate students, staff from BEU and other schools, in addition to professionals. First, I would like to welcome all workshop moderators who are joining us in this session today. Now I will share the bio. Okay. Now let me introduce the first workshop moderator, Mr. Yang Song, an architecture researcher and multidisciplinary designer who has projects on architecture design, augmented reality, and digital fabrication. He has an MArch degree from the Bartlett UCL and is now a practice-based PhD researcher at the Center for Architecture and Visual Arts, University of Liverpool. Unfortunately, Mr. Yang cannot be with us in this session. He sent a pre-recorded video for his presentation. So we will play it now.
Hello, everyone. My name is Yang Song. I'm the moderator of the ASCAAD 2022 Workshop 1, AR Plus Design, Augmented Reality Immersive Design Method. I'm really excited to hold this workshop for our conference this year, and we got 44 participants this time. And we spent a great time together to explore the design methods in the augmented reality environment, which is very fresh and new to all the participants. So first, I will give a brief introduction about myself. My name is Yang Song, and I got the master degree of architecture from the Bartlett UCL. I started to do the cross-disciplinary research related to architecture design and augmented reality technology. And now I am a practice-based PhD student from the research group CABA, the Center of Architecture and the Visual Arts, University of Liverpool. So I continue my previous research direction and try to add the robotic fabrication technology into the AR-assisted workflow to explore the interaction between human, robots, data, and their mutual relationships throughout the immersive design to fabrication process. According to my research process, the whole project is divided into 4 main parts, including the AR-assisted immersive design, AR-assisted physical stability simulation, AR-assisted robotic assembly, and AR-assisted human-robot collaborative fabrication. So our AR class design workshop is from a part of my preliminary research outcome. This is the schedule of the workshop on the 10th of October. So basically, I introduced my PhD research step by step so that the participants will learn more about the purpose of this workshop, as well as the meaning of AR immersive design in my entire research process and why I am doing this topic of research. Next, I gave the participants a basic introduction about the AR technology and also some case studies of using AR technology in architectural projects from design to construction process. And after that, which is the most important part of the workshop, is the tutorial based off the basic AR assisted functions and the parametric design algorithms. So I did a step-by-step live show for all the participants of my AR immersive design workflow in Grasshopper. And most of the participants, they haven't heard or used Grasshopper before. So I just let them to get familiar with the parametric design tool and the logic. And after that, I shared the file with them and let them to play with the specific parameters. Because the workshop has limited time, so I think participants can involve themselves more effectively using this method, like playing with the specific parameters from my coding file. And after that, the final session was the design algorithm development and the Q&A. So this online workshop aimed to introduce the knowledge of exploring immersive parametric design through augmented reality environment. As the 3D to 4D design file, architectural design has been limited throughout its history by 2D to 3D representations. Even though computer-aided architectural design and modeling software is widely used to produce digital 3D models, the conventional screen-based visualization methods for design and analysis are still restricted to how well the user understands the space on a computer screen, as the design is done outside of the building set. Hence, there might be disparities between the design and final outcomes. Ideas like exploring immersive design in AR, as well as real-time modification experiments and interaction with building environments and the Metaverse, will therefore accurate as the central core of the research theme to reduce the current design method. So participants learn about the parametric design method of brick-based structure as the demonstration. Basic AR modeling logic, AR on-site holographic preview, AR real-time interactive functions, and basic AR input methods. So participants were able to learn parametric design process and the AR immersive design by following live demonstrations in Grasshopper with the related plugin set up step by step. After that, participants will start to design, develop, and preview their own structures in AR environment with setting-related interactive immersive design inputs. The goal is to enable the participants to learn and apply this immersive design method to architectural approaches, such as walls, columns, pavilions, or other structures, and to customize the design algorithms or related interventions to their design in the AI environment. So there are 44 participants in total, and most of them are doing architectural design or interior design. Therefore, the results of the workshop are better because everyone has relatively background knowledge. So the workshop outputs are submitted in the form of videos and pictures. For the video, participants use the mobile phone to access the demonstration of the AI immersive design through corresponding learned skills from our workshop, and preview the design structures in real time, overlay the physical environment as AR holograms. So here are some outcomes from our participants. We also have more fancy structures that was done by our participants. So through this workshop, participants have learned the basic logic of AR design, as well as the basic interaction functions required for AR immersive design in Grasshopper. So these ideas and attempts will help beginners as them enter the AR immersive design process faster and more effectively for the further developments. So that's all for my workshop outcome. And if you are interested in my research and want to learn more detailed information, please feel free to email me or follow my research Instagram account at ysdesign.studio. Thank you for listening.
Our second workshop moderator is Dr. Fatima Belok, Assistant Professor at the Faculty of Architecture, Beirut Arab University, Tripoli. She organized many workshops on parametric architecture using Rhino and Grasshopper 3D. Dr. Fatima, please present your work.
Hello, everyone. I will share my work now. So can you see my screen?
Yes.
Okay. Okay. I'm Fatima Belok, Assistant Professor at Faculty of Architecture, Design and Built Environment at Beirut Arab University. The workshop topic was about interactive digital parametric pattern using Rhino and Grasshopper. The workshop was number 2. It was mainly about Rhino and Grasshopper. So Rhino or Rhinoceros, which is a 3D computer graphic, a computer-aided design CAD application software. And Rhinoceros is basically mainly work on NERV's mathematical model, which focuses on producing mathematically precise representation of curves and freedom surfaces. In Rhinoceros, we have a plugin called Grasshopper, which is a visual programming language and environmental that run within the Rhinoceros 3D. So in 3D, we have plugin called Grasshopper. In Grasshopper, we have lots of plugins that could be introduced, such as environmental simulation plugin like Ladybug and Honeybee. But in this workshop, the focus was on 3 main plugins, which was Lunchbox, Firefly, and Weaverbird. The main one was Firefly. Here is just an introduction for Lunchbox. What is Lunchbox plugin? Lunchbox plugin works on putting panels, different examples of panels on surfaces, such as diamond panels, hexagon panels, random, squid quads, triangulation, and other type of panels. It also could work on trusses, creating structure, and grid structure, hexagonal structure, and other type of structure. While Weaverbird works just on meshes, such as we have cut milk carts moving and split meshes into quad. The main one was Firefly, in which is focused on introducing sound. These are some examples of Lunchbox and Weaverbird results. It is just based on surfaces and that could give me patterns. So these are some examples. The main plugin was Firefly. Firefly focused on giving input. This input could be a sound, a music, or a voice. Then the process will work to give me an output. What could be this output? This output could be interactive parametric pattern. So I introduce a sound that have different frequency, and this different frequency will give me different parametric pattern. For example, here, if we have here this facade, this interactive facade, we can see the difference between the pattern. Each differentiation between the pattern is based on the sound. If the frequency is high or low, it differentiates the pattern. So based on the music or the sound, we could have different patterns. So this was one example. The focus on this presentation is mainly on the work of the students. So let's see the examples of the student work. Actually, each student has present like an A3 paper, having putting all the designs and work during the workshop. We have started by what? We have started, first of all, by putting a small sphere. This sphere, we have introduced, for example, sound of the student or any music that they want. And we have turned the frequency high and low. So the spheres start to move on based on the z-axis, up and down. Then we have added more spheres. For example, here we have 5 spheres that move up and down based on the sound itself. After that, we have moved to other more complicated examples in Grasshopper. We have worked a little bit on creating surfaces in Rhino, then transporting these surfaces into Grasshopper, using Lunchbox and Weaverbird to create a pattern on the facade. So they have created pattern on the facade as shown here. Then, as we can see, each surface we have created 3 different patterns. Why we have 3 different patterns from each facade? Because the students have baked 3 different levels of thickness based on the sound. They have put a very low sound, they have put a higher level of frequency and a more high. So the thickness will value by the frequency of the voice. So it was very thick, very thin. The thickness become more and more based on the sound. Also, we have tried on different type of surfaces. For example, on different tower based on the rotation. We have tried different components such as rotation, such as the using series and different type of components and also different type of pattern. And here was the Grasshopper plugin. As you can see, they have started by very simply Grasshopper connection. Then we got more and more complicated to understand more and more the idea. Here is another example, for example, for Ali Shaib. He has created a passes for passengers. So he have created like octagon, and this octagon have a certain rotation created on the Grasshopper, Based on the sound effect on the surface, he has created different thickness also for the surface. He has also worked on something called attraction. What's meaning by attraction? Attraction, it's based on a point closed curve. They have selected a point, for example, at the center of this surface, they have created a point. And when we get more far from this point, the surfaces become smaller or bigger. So also they have worked on the attraction point. Here also they have worked on the attraction, but based on the z-axis. So we can see if these are buildings, for example, these buildings become more high till the end. We can see different example here for Namat, for example, on also on the attraction, and she has created a shading using now a Cotmilly-Clark in Weaverbird that work on meshes. So she had transformed the surface into a mesh. So they had the knowledge how to transform the surface to mesh, then the mesh to Cotmilly-Clark to have a smooth pattern. And this smooth pattern, how to change its width. Also here, another student. The main focus in Firefly was on what? It was on something called sound capture. We have a main component called sound capture that capture the sound. Then we have a timer. We should specify the time, for example, 20 milliseconds or 10 seconds to capture the sound. Then we have something called remap and constructing domain, based also on the frequency, if it's very big frequency or very small frequency. Here is another example. Here also he have designed a building, and as we can see that each student has its own design. So we have focused that each student has to put his identity in each design. For example, here, this student has used the Voronoi pattern and the attraction at the same time and has introduced a sound. Here is another example. This is also based on the attraction, but on something called series and extrusion, and also on the sound, as we can see here, the sound interaction. Also here, the work was on Lunchbox using the triangulation. In all of the poster, we can see they have used 3 different items: Lunchbox, Weaverbird, and the sound, which is Firefly. And these are different examples. Some of students start to create their own project. For example, here is a student has created an aquarium and put concepts and idea like this using DOM. This was a design for a surface, and this also was designed for a dancing tower and the passage. Now we will see a small video for the movement of the facade and the pattern. So just I will show you the video. It's just 1 minute. This is the attraction based on the sound. And finally, I would like to thank all the participants for their hard work and for their time with me. And thank you for all the organizer of this amazing conference and workshop. Thank you so much.
Thank you, Fatima, for your great work. Now, our third workshop moderators are Dr. Laila Turki and Dr. Abdelkader Ben Saki. Dr. Laila is a Doctor of Science and Architectural Engineering from the University of Carthage, National School of Architecture and Urbanism of Tunisia. Worked on parametric design for urban fabric optimizing, certified for Autodesk Pro Revit, expert in parametric modeling, BIM, visual programming, a key lecturer in sciences and techniques of architecture at the National School of Architecture, researcher at the AEUC Creosote team, expert in architecture digital approaches, BIM, parametric modeling, energy performance, generative design, and machine learning. Dr. Laila, please share. Hi, you can share your presentation now. I will stop this share. Okay.
Hello.
Hi,
Seeing
Dr.
my
Laila.
screen?
We are hearing you.
Okay. So hello, I'm Leila Koubha. I'd like to present the workshop Generative Design by BIM Approach. We have animated on behalf of ASCAAD conference during 2 sessions on Monday 10 and Tuesday 11. This workshop was conducted by me, Dr. Leila Koubha from Carthage University, and with Professor Abdelkader Ben Sassi from Grenoble University. The workshop gives basic exposure to generative design on BIM environment. It gives hands-on experience on how to create visual scripts and run a generative design process. The program was presenting Dynamo interface, creating algorithms on Dynamo, creating and running generative design study, and BIM study on Revit. Even the technology evolution until now, if you look at the tools that we have, they all have something in common. And that something is that these tools require somebody to operate them. So they are passive and they require some skills to operate them. So even these tools on the left side, even the tablet or computer, which is something more advanced, they are all passive tools and they all require somebody experienced to handle them. What we are seeing now with the help of the technology that we have right now, we are seeing new ways of doing things and our tools become generative. So generative design is using actual algorithms to synthesize geometry, and all it needs from you is your goals and your constraints, and it will generate options for you. Parametric modeling, which is a feature that we can find in today modern software, is using some simple concept. We can create a relationship between parameters, like in this case, we have parameters A, B, and C. And so this A and B can always change value, but the relationship between them will be dysfunction. So we will always associate these two parameters. In the same way, we can associate in geometry and we can create constraints between geometric entities. In general, the principle of generative design is quite straightforward. We're essentially taking a branch of inputs, usually numbers or something that numbers can drive, and we are randomizing and shuffling these values in a range. What this does is gives us the ability to influence on them many times over and over again, and we generate multiple studies using these algorithms, and then we can collect the goals or the measurable components of the script. So how successful was our study, and we can use these goals to analyze and optimize the best options of our studies. And essentially, this is the basic gist of generative design in general. We learned about BIM, Revit, parametric and visual programming with Dynamo, and about generative design, which is an Autodesk product. And we saw some techniques and examples of how we can use new design approaches in order to generate evaluating cycle through the design process. And we presented the difference between the traditional design methods that we have used so far and compared with generative design techniques. And now we can use nodes in order to create your own automation. So in order to create your own automation, so from difficulty perspective and expressive power, Dynamo stands before Revit, and so you can solve a lot of automation using these tools. Of course, if you know programming language, you will be at the crown of the top of the tree. And generative design workflows help you explore a solution for the big problems of by rapidly testing, analyzing, and evaluating designs and iterations for the challenges that matter. Now the tools are changing and explore new ways to find the shortest time to design things, and also the session was about a design that can help automate and improve the design process. With generative design, we can create thousands of options, and also we can also optimize these options. So generative design is actually one human computational algorithm and ultimate the cloud computing power. So combining these three, we can generate thousands of design options. So you have to understand what you want to achieve, define your problems. This requires you to know how to use Dynamo and create Dynamo scripts. Also, you need to decide in ways to measure success and think about how to review the results. So using algorithm, you can decide what problem to solve, what goals must be achieved, and what factors are most important to solve these problems. So how does it work? Well, we generate multiple studies to find the best outcomes. So there is going to be 3 ways or 4 ways we can do this using a generative design tool in Revit. So the first one is randomizing, so we can keep running the study in multiple sessions over and over again, and we can filter through the outputs at the end and just find the best result. And you can do what's called cross product, which is where we generate every single possible outcome so that we can fully analyze the results. We don't tend to use the cross product because it's pretty slow and it does a lot of results. But if you are really needing to get the absolute best of the best, this is the way to do it. And we can also use a method called optimize, which generates multiple tests. And we're only going to see the most successful tests out of each batch of tests. So this way, you don't see the really bad results, but only the ones that are almost the best of the best, and then you find the best of the best of them, essentially. And also you can explore like this. I prefer using this show hide parallel coordinate to explore outcomes, dialogue, constraints display as a follow. In the list view of inputs and outcomes, so you can clearly identify which value change for each outcome and which value stay the same. For the first day, we focused on Dynamo basics. So to create a model for generative design study, We began by developing a common understanding on the mechanics of dynamo, then move on to build a set of graphs together that will include some basic geometric applications and Revit integration. For the first application, the object was to introduce parametric modeling via Dynamo, and the exercise consists in setting two volumes by declaring variables or inputs and outputs evaluators, which represent the objective of generative design. Revit Dynamo generative design were used to study the volumetry of buildings through an iterative process that generates outputs to satisfy certain constraints. The first step is to define inputs and variables depending on the ultimate goals. Then the last step is to select the optimal solution. On the second day, we focused on adding evaluators and generating design options, and we went over the fundamental of optimization and how to frame a design problem in terms of goals and constraints in order to drive multi-objective optimization and evaluation in generative design. We explored the various ways our problem definition can affect the result of the optimization. We exported optimized solution on Revit for BIM study. So the second exercise was a slightly more advanced application. And the first part consists on parametric modeling. We gave participants a program core to complete with Dynamo by adding evaluators. And the second part consists on testing various methods of creating a study with generative design and visualizing results. And the third part was to export the result into Revit to generate a solar study and explore BIM study. Once the optimal solution has been determined, it was possible to import these results back into Revit environment to complete the BIM modeling study. During this workshop, participants learned how to build geometry generators and evaluators using Dynamo, and how to use these generators and evaluators to drive multi-objective optimization toward specific goals on generative design, and how to use generative design tool to evaluate the generated optimal solution and integrate some of these designs back to Revit for BIM study. We'd like to thank ASCAAD organization committee and all participants for their great work, and we will be available to help on the topic of this workshop. So thank you.
Thank you, Dr. Leila and Dr. Abdelkader. Thanks for you. Now, let me introduce the moderator of workshop number 4, Dr. Samer Sayari, an assistant professor of architecture, BEU researcher, and award-winning architect with a special passion for outer space architecture. He is also an Autodesk certified instructor in Revit since 2012. He received more than 40 national and international awards, and his work has been exhibited in several countries and featured in many channels worldwide. Dr. Samer, you can start your presentation.
Thank you, Dr. Karim, for the introduction. And let me just share my screen.
Okay.
Okay. So the workshop that we have concluded last Monday was zero energy houses. zero energy houses. It is a pressing issue in today and modern days contemporary problems, the issue of energy. So we have combined the zero energy knowledge, or how can we design a passive house using the Revit and the BIM technologies. So the manifesto, I would like to introduce my manifesto first. It is digging deep in the rules of universe, including our heritage, our legacy, applying those rules using cutting edge technologies, in our case with the BIM and Revit and some simulation software. And number 3 is delivering this system of knowledge to the future generations, as we have done already in this workshop. These are a set of projects. It is a line of research that I have started since 2011, combined with the cutting edge technologies of the BIM. So the line of research and the line of practice and awarded projects are all fused in just one fusion pot, which was introduced to the students last Monday. So the workshop was an interpretation of this paper, which was published in a Q1 journal. It's my work, me and my colleague, Dr. Osama Omar, and it was about designing a BIM energy consumption template. So the template was delivered to the students. The template will enable them to calculate and achieve a net zero energy house, which will raise awareness to the consumption and the rate of consumption and consumerism of the residents of the house, and hence they can recalculate and use it as a decision supporting tool from the early conceptual phases of the design to start the designing in a passive way. This is the project also that were introduced to the students was awarded internationally in several venues, and one of them, we first started an introduction to the passive houses and how can we understand the basic fundamental principles of designing a self-sufficient house in terms of not only energy, but energy, even the food and water production, and is a complete sustainable approach. So the first presentation was for the Plus House, and the second one was, which was the main, was Beit Suhaimi. Beit Suhaimi, it is an awarded project, and that plans and the Revit file of this project particular was delivered and passed to the student to start experimenting and designing, and hence taking it as a role model so they can take the steps and take the lead in their own design projects. Sorry. It's a little bit. Okay. So the first slides is a simulation of how the passive approach of designing a building without the need of any kind of AC or heating system, and using and downloading the EPW files, which contain all of the climatic data of Alexandria City from the US State of Energy Department website. And after running some simulations, and including the daylight simulations also, to conclude that the design could be done using the daylight at least 8 hours per day without any need for any kind of electrical or lighting equipments. And then a basic calculation method to compensate all of the consumption of the energy using the solar panels, and reaching the level of decreasing the carbon footprint of a building. Another also example which was applied in Arizona, so which proves that zero energy houses could be applied anywhere depending on the environmental parameters and the specificity of the site. Also, some simulations were undergone, and another house, which is the Eco House in Sinai Peninsula, which was sponsored by the Egyptian government in 2014 for the Bedouins of the place there, and also the same methodology was applied to reach a zero energy house. After a series of projects to demonstrate and pave the way for a good understanding and maybe lay the fundamental principles of having a zero energy house and a passive design. Last thing was the project itself and the application itself. So as I have mentioned earlier, the template was passed on to the students alongside with the projects and samples of the project that have been demonstrated in today's presentation, and the basic calculations were concluded. So there are two kinds of schedule: the electrical power consumption and the lighting power consumption, and it was separated. They were separated just for the ease of calculations, and including the total balance sheet. So the parameter here is having not 0, but minus 0 point something, not the 0, 1, not the minus 1. So if the conclusion, if the result was minus 0 point something, so that was a successful zero energy house. And that was the only parameter to achieve. The compensation was done with several types and variety of models of the solar panels downloaded from the market and applied into the template. Not only the students were learned how to use the template, but how to modify in the template, how to include new devices, or maybe modify in the existing devices. We are very sure that the today's accelerating pace of technology carries every day a new invention and a new electrical device, and maybe a modification, and maybe a star rated kind of device. So they should have the capability of modifying and editing in the template and to push the story of the human story forward. So I had the honor to head this workshop in Beirut Arab University. I would like to end my slide and the presentations today also as one of the scientific members by those three quotes, which it's no coincidence that they do resemble. The first quote goes like this: "The future belongs to those who dare to dream." And the second quote by Eleanor Roosevelt goes like, "The future also belongs to those who believe in the beauty of their dreams." And the last one, "The future belongs to those who prepare for it today." I would like to extend my thanks to all my colleagues and to Beirut University, Dean and Mr. President and of course the organizing committee of ASCAAD for concluding today's presentation. Thank you so much, and I hope that we can meet again in future events.
Thank you, Dr. Samer, for the very interesting topic and workshop. Thank you. Our fifth workshop is GIS-based parametric urbanism. Unfortunately, the workshop moderators from ESRI couldn't be with us today. So thank you for your presentations and for being part of the ASCAAD 2022 conference. And now I will leave the floor to Dr. Debbieh Mohsen. Thank you.